So we mentioned the new space companies. The latest incarnation of this is SpaceX and Blue Origin, maybe the most famous ones. And to me, they look as they have a common factor, which is reusability for the rockets. So we were discussing a bit offline before about the concept of reusability itself and why it is so crucial for the new space company. Can we discuss a little bit?
Okay, so yeah. New space, the term new space depends, it's various things to various people, but yeah, it relates to something that happened in the late 90s where people started to think about the new generations of, or let's say new opportunities to do things in space that would be enabled by new generations of reusable launch vehicles. So the key to, in my mind, personally, the key to new space is to understand reusability and how it can play a part in developing our access to space. Because as Heinlein said, I think I've quoted this before, once you get to low Earth orbit, you're halfway to anywhere, which from a delta V point of view is very true. So going back, the concept of reusability, the history of space and launch vehicles is that launch vehicles, as we know them, came out of ballistic missile technology. So this is more ammunition or munitions type engineering than it was sort of vehicle engineering like aircraft. People in the 20s, Goddard and others, and Tsiolkovsky before him, and then of course von Braun in the 20s, 30s and in the 40s, always envisaged being able to reuse vehicles because, as with the aircraft model and most transportation models, you don't throw away your vehicle after you've used it on one mission. So reusability is a concept that goes back to the very beginning of this sort of ideas about space vehicles. The fact that we never went down the reusability path to begin with is partly, primarily due to the fact that the advancement of launcher technology came out of munitions, so using rockets as weapons, which obviously don't need to be reused. And the technology was developed, as we all know, in the Second World War, particularly the V2, and then was picked up after the war by both the Russians and the Americans through the German engineers as well, who they picked up and was then used as part of the Cold War to look at long-range weapons, primarily in the 50s for projecting and throwing bombs, atomic weapons over large distances, so ballistic missiles. And that technology had massive amounts of money invested into it. So when it came to how do we get people, or how do we get objects into space, people eventually, the first thing that came to hand was ballistic missile technology, munitions technology, which was expendable, not reusable. And because of this idea of the space race and people wanted to get into space first, the path of least resistance was chosen. So all of the early launches were performed with expendable vehicles, and that philosophy took hold again when we had the moon race, which, as we discussed before, was another extension of the Cold War. And so the path to reusability was something that was always there, always known, and the rationale for doing it was always known, but the opportunity to actually exploit it was never taken because all of the momentum, all of the money went into the munitions side to get the job done, whether that was launching ballistic missiles or launching men to the moon. It had to be done quickly, so you used what's available. However, the philosophy of reusability was still something that people wanted to achieve. And some people argue there was a strand of development, particularly through things like the X1, Bell X1 that broke the sound barrier, up through to the X15, which was actually a technological strand that would eventually have built up to a reusable vehicle. Some people even quote the X-20 Dinosaur as a first reusable shuttle, even though it was launched on an expendable Titan III. But there is an argument that says, had the moon race not happened, reusable vehicles would have actually developed naturally out of the hypersonic program. I think that's a moot point because it assumes quite a few things. But history shows that the only time that reusability came to the fore in a major program was when the shuttle was envisaged. Of course, the shuttle was something people had been looking at reusable concepts during the 60s, all on paper, and proposing things. And it was only when the Space Task Group of 68 and all that looked at what they would do post-Apollo. They had grand visions of launch vehicles which were fully reusable, and by having something that was fully reusable, they believed that that would enable them to develop deep space infrastructures. Of course, that didn't happen, and the shuttle became a semi-reusable, some would say refurbishable rather than reusable vehicle. And that happened, I think we mentioned this before, through reasons of budget. That the post-Apollo program was limited by funding constraints that Congress set down. And as the various components of the Space Task Group, the Mars vehicles, the NERVA rocket engine, the space station, all got cut from those actual programs. The shuttle was the only thing left. The shuttle was still seen to be fully reusable, but then in about 1970 or 71, Congress looked at the budget for the shuttle and saw that it would have a peak funding level of something like $4 billion, which was a fully reusable shuttle. So the funding is like a sort of a bell curve, a flattened bell curve, and the peak was $4 billion. And Congress sent the message back to NASA, if you want the shuttle, you have to cut down that peak from $4 billion to $2 billion. And this is where NASA then fell back to the semi-reusable shuttle, simply to get through the funding for the development phase. Having said that, they were completely aware of what that meant in terms of the operational phase, because it would mean it's more expensive to operate. People talk also about how budgets overrun. One interesting fact about the shuttle is that in 1971, when it was agreed to go forward with the shuttle as we now know it, the projected budget for the development was $5 billion. It actually came in at $5.1 billion. So in terms of budget overruns and things like that, that shows that even in those days they could do estimation of costs quite well. So back on the subject of reusability, what is the thing about reusability? You've already mentioned, well, you don't throw vehicles away. If you can, you don't take a 747, go across the Atlantic and then burn it at the end. You reuse it. And this is all to do with the overall economics of the vehicle, because reusable vehicles are very expensive. Expendable vehicles are very expensive, but not as expensive to develop as reusables. So in order for, if you like, a trade-off between why would you build a reusable over an expendable, the sensible economics there is, okay, if you look at the overall mission, the overall life cycle of the vehicle, how many missions it's going to fly, if you actually do a plot of, and you start the plot off at the 0 point where you have the development cost of the expendable is at, let's say, 1 on the y-axis, and the development cost of the reusable is, let's say, 2 on the y-axis. And then on the x-axis, if you project that along there as number of flights of the vehicle over its lifetime, and you then, from those two start points at 0, the slope of the line you project is effectively the cost of every flight. And the theory is that the expendable cost is very steep because you're building a new vehicle, whereas in principle the reusable cost is very little. So the reusable line goes quite shallow, and at some point in time they will cross. And the point at which they cross is the point where the number of flights you envisage for your system, that would be the point where you could say, okay, now for more flights of the system over its lifetime, it's better for me economically to choose a reusable vehicle because of the overall cost if you integrate onto the curve. Whereas if I'm only going to fly a few times, it's much better for me to develop an expendable vehicle. So it can all it comes down to economics. But of course the slope of those lines has many assumptions involved with it. In particular, the cost of the expendable could be brought down by improved manufacturing. Effectively, if you could 3D stamp the things out, it then just becomes the cost of the materials. On the other hand, with the reusable, if it takes an enormous amount of effort to effectively rebuild the system, then what you assume is a shallow line, the incremental cost of every launch, suddenly becomes massive. And this is what happened with the shuttle. The cost of actually refurbishing the vehicle was probably more than the cost of an equivalent expendable. So this is why the shuttle costs didn't really make sense, and shuttle economically was a terrible failure. Technically, it was a marvel, and it was a sort of one of the 7 wonders of the modern world. But economically, if you had the money and all you wanted to do with that money was get things into space, you'd have been much better taking that pot of money and building expendable vehicles. But this is all in hindsight.
Actually, I remember you mentioned this new factor in what we are seeing emerging on the market, the fact that both Jeff Bezos and Elon Musk are businessmen. And so I believe they can do their math very well when it comes to money. Because also, one of the discussions we have in our community is how these calculations are done, and you explained it very, very effectively, because there is, of course, also a convenience in serializing the production of something. So say that you want to fly many missions because now SpaceX has some technology, has also an appeal on the price because they cost much, much less as a target price, as a price on the paper compared to other competitors. The discussion is basically based on this. When are they going to break even? When are they going to really make money by reusing? How convenient is reuse the same stage 100 times compared to the cost of serializing the production of 100 new but very efficiently streamlined first stages, for example?
This is one of the conundrums, and this is why the debate over reusability versus expendability is a very complex subject. And it's not something that you can come to definitive conclusions about at the moment. Not necessarily because of the technology, but because of the uncertainty over markets. And this is why when people criticize Ariane, for instance, with coming up with Ariane 6 the way they have, and they say, look at what Bezos and Musk are doing. That's the reason that Ariane choose to do the expendable version as opposed to fully reusable version, is because they're looking at the economics as to what it's going to cost them to develop it, but more importantly, what markets they can expect to capture during the system's lifetime. And this is where the benefit of reusability really does depend on what markets are out there. And most people who've done the analysis say that, just as a rule of thumb, if you're going to get a cost with current markets, which basically boil down to ComSats, commercial markets, now launching for NASA, launching astronauts, that's a different thing. But really the only current market we have that's real, that you could take to the bank and get money from an investor from, a real market, is ComSats and weather satellites and polar orbiting systems. But today, ignoring mega constellations, ComSats are the only market. And you can see that the number of ComSats that are deployed every year is quite well defined, and it's not about to increase. And more importantly, when you look at the economics of a ComSat operator, the development cost, the launch cost versus the revenue they pull in, the actual cost of launch is a relatively small factor of the investment that they make. So what I mean by that is, if I come along and say, okay, currently you, Intelsat or whoever, spend 70 million to launch your satellite, but that satellite has cost you 500 million or even more, 700 million, something like that. The cost of the launch is probably only a tenth of the overall cost. So if I drop my price from 70 million down to 20 million, sure, I've saved the launch cost of 50 million. But compare that now to the overall cost of the satellite system, and it's small. Even more, though, if I now say to you, okay, you're going to be launching on this low-cost launcher, whether it's reusable or expendable, but I can't give you the statistics on how safe it is, so you'll be the first one to fly it. They're people who do all their actuaries and their risk of insurance and things like that will say, you know, it's not that we'll risk losing the satellite and have to build another one, but any delays will actually delay us into the market. So the revenue that satellite can make once it's on station, you know, 1 month's loss of revenue on orbit is actually probably far more than the cost you're saving. So this is why a mature ComSat operator would probably plump for something like Arianespace or something that's got a nice, long, mature track record than some new upstart that can drop the price, can halve the price, but can they guarantee that they can launch you safe and on time? And that risk is something that the satellite operator has to balance. And up to now, very few have gone for it. It's starting to now transition with SES in particular, going with SpaceX. And once SpaceX build up a track record, there'll be more people going there. But again, the thing about it is that it's somewhat insensitive to price. There's other factors that are in there. So price isn't everything to bring down the cost of launch. So that's one factor. There was another factor now, I've forgotten exactly what I was going to say there.
The magic of post-production is that whenever you remember it, we can squeeze it in after the
Yeah, this is true. Yeah. There was another factor about the actual cost, which is that to the operator of the launch vehicle, the launch vehicles, if you drop your price, your market price, in a typical market, any product, you drop the price, you drop the price of butter, and hopefully people buy more of it. Yeah. And this relationship between dropping price and the increase in the number of products purchased is called elasticity. And the sad fact about the launcher market at the moment with communication satellite is there is very little apparent elasticity in the market. And again, the reason is because if I drop the price of my launch, it doesn't actually benefit the communication satellite operator that much. So looking at it from the launch vehicle operator's point of view, if I drop my price from 70 million down to 50 million, I've just lost myself 20 million in potential profit, because let's say my vehicle only cost me 30 million. So before I was making 40 million in profit, now I'm only making 20 million. So unless my flights I'm booking can double, I'm not breaking even. In fact, I'm losing profit. So this is the dilemma that launchers have, and it's all driven by the elasticity of the market, not even the existence of the market, but this property called elasticity. And that is another factor which has prevented people from going to reusable rockets. Because yes, sure, reusables could drop the price. And at the moment, SpaceX are talking about going from a Falcon 9 flight, I think on the web is posted at 62 million. And they're talking about being able to drop the price maybe when they really have full reusability down and they've amortized it down to 20 million. But if they can't get the people to come into the market to increase the launch rate, then they're going to lose money. So reusability doesn't actually benefit you at all, you as a launcher operator. So I guess having gone through all these little factors, the point to bring out of this is that choosing to design and put your money into a reusable system is not just a simple case of, is the technology there? It's also, are the markets there? Are there not just the necessary markets, but sufficient of them? And is the nature of the market such that if I do provide lower costs, lower price launches, that the market will respond and grow? And at the moment, the answer is, for pure communication satellites, no. Which is again explaining why people are reluctant to go to reusables. And I think the reason that that Musk and Bezos have gone this way is they have a sort of almost an implicit belief that eventually, build it and they will come. But it's a belief, and it's a belief that you couldn't build a business case around and go off and raise money on from investors with, which is why they're doing it off their own pocket, out of their own pocket.
Yeah. In particular, Jeff Bezos. I was reading an article I mentioned to you a while ago. This morning he threw another $970 million worth of actions on the market to inject more money on Blue Origin. So, but on the other hand, I also think this means that by the time a potential market starts, or by the time they will be ready to offer the services on the market, in particularly Jeff Bezos, since SpaceX is already offering services on the market, the development costs are gone. So now they just have to be spread upon as many launches as possible.
Yeah, you amortize the cost of your development over more launches, which means you can lower the price. So that is one way of justifying the investment in reusables. Now, be aware what we've talked about so far is developing reusability for a commercial company. There are other people out there who want to develop reusability for other factors. And of course, those other people tend to be military. What we've not discussed yet is the reusability advantages for military purposes. And here, with the government being able to launch rockets on demand, this has always been the selling point, that they can immediately access space on demand. You can launch this thing just like you can launch a strike aircraft or something like that. So that's always been the selling point for the military side of things. And not only that, but these vehicles can give you capabilities which ordinary systems couldn't be. So you could launch and do some reconnaissance over a certain area very quickly. This is another potential advantage of reusable systems. So that, from that aspect, reusable systems, reusable launch vehicles have been looked at seriously by the American military, definitely. They had a really big effort in the 70s in parallel with the shuttle, and certainly in the 70s and then the early 80s. There were certain programs which are now just becoming sort of known. They were secret beforehand. which did look into serious, let's say, technology development to the point where they could field a practical, reusable vehicle. Programs like Copper Canyon and other things were looking at propulsion systems, and of course, one of the things was air breathing, of course, single stage to orbit and things like that for reusability. So lots of technology programs were going on in the 70s and early 80s to develop hypersonic vehicles which would be capable of orbit. Whether anything was actually fielded in reality, I don't know, certainly. I've heard lots of rumours that there were systems. Aurora is the most famous sort of hypersonic mythical aircraft, which would have been a follow-on to the SR-71 and things like that. And that sort of technology would have been an ideal platform for a booster stage for an orbital system, or even a follow-capable single stage to orbit, which is where the National Aerospace Plane X-30 came in the late 80s. But people were certainly doing these technology works. They not only on the propulsion, but also on the structures. I think they built some flight weight structures of fully reusable systems. And the rumor I heard was that, well, it was more than a rumor, that Boeing was so confident in the late, I think it was the late 70s, early 80s, that they proposed to build something called RASAF, Reusable Aerospace Plane, which had been launched on a sled. And I think that would have been sort of, if not single stage to orbit, it would certainly been a pop-up thing which would have put something into orbit as a second stage. And the story I heard is they actually went to the military and said, we'll do this as a sort of a normal contract. They were so convinced they could do it. It was never taken up, but other concepts were developed over those decades the military were looking at. And as I say, the X-30 NASP was the most obvious one back in the late 80s. Unfortunately, that faded because I think it became more and more obvious that people's understanding of the real technical challenges was a little bit too optimistic. Added to the fact that I think the military also realised that the need for these vehicles wasn't actually that high. So this is one explanation as to why they never developed the SR-71 follow-on. Although again, people say they developed it. The stories I've heard is that they developed something, but operationally it was a disaster. We'll never know, or maybe sometime in 100 years we'll know. So there was so we went from the shuttle in the late 60s, early 70s to aerospace planes on the military side in the late 70s, early 80s, but nothing from the commercial side. Gary Hudson did propose things like his Phoenix, which was based on some McDonnell Douglas designs from the 60s for single stage to orbit, vertical takeoff, vertical landing. But nothing was done until the beginning of the 90s, when there was a second wave through NASA to look at single stage to orbit, because people believed that they had some breakthroughs in the propulsion side of things and they could do this. And this is where several studies, rounds of studies were issued. One derived the DCX in the early 90s. And then following that, there was the competitions for X-33, which Lockheed Martin won. So that was then the next iteration of fully reusable, but in this case single stage to orbit concept, which was probably a step too far.
I remember the X-33 struck me when I was younger and reading avidly about it, because of the design of this rocket propulsion system with this aerospike engine.
Yes.
Without a clear, bell-shaped nozzle, was something completely alien to me. I mean, I couldn't grasp how could you make it work, And I thought it was fascinating, and I was really following with a lot of hope the development stages of this product. Actually, I was reading about it on the Journal of the British Interplanetary Society, and they also always covered quite well this project. And then at some stage, it went away. But I just want to throw out one thing, because you mentioned the military with the aerospace planes, X-37. That's a fascinating one. What they are doing with the X-37, launching this object in orbit, stays up there for months. It looks like from what the amateurs astronomers are able to do, it has the capability to substantially change the orbit. So it means that it has some fuel on board to do delta V's, so do some interesting stuff, and then fly back. And I just want to let it out there, and maybe you have something to say, or maybe not. But that is actually, looks to me like a very successful project, which is actually paying off now for the military. We don't know what it does, but whatever it does, it has impressive numbers in terms of time spent in orbit and maneuverability.
Yes, indeed. What you're actually seeing there is effectively an unmanned version of Dyna-Soar X-20, which was the experimental version, which would have gone operationally as Dyna-Soar back in the 60s. This is for the want of a better word, a winged capsule, because the launch vehicle, again, is an expendable system. With Dyna-Soar, it was going to be Titan III. With the X-37B, it's actually an Atlas V. And indeed, the propulsion system, though, on the X-37B is a peroxide system, so they have substantial capabilities for in-orbit delta V changes. But again, this is a concept that is essentially developed from, it's actually legacy items from some crew capsule return work that was done in the 90s. And various things. It was then shelved, and the military picked it up as essentially a readily made design, and they implemented it. So this is something, again, it's more of a legacy item from concepts that were looked at in the 90s. But yeah, the 90s was a strange period, because people were looking for how do we improve on the shuttle, because obviously there'd been Challenger at that point, and people knew, because of the operational experience, that shuttle was very expensive to run. As a national treasure, a technical wonder, but economically this was, it had capabilities which no expendable at the time could do, so it was certainly useful, but it was extremely expensive, so people were looking for better ways to do this. In parallel, in the 90s, there was the evolvable expendable launch vehicle, which as a result came out, the Atlas V, the Delta IV, and things like that. But the 90s was a time when people were looking for alternatives. And so X-33, and in fact there was something called X-34, which was a sort of a smaller version, which would be fully reusable, but a suborbital stage, initially launched from the back of a 747. Orbital Sciences tried to made a proposal that was essentially a partly reusable Pegasus type of system. But they failed. There's an interesting backstory to X-33 and the bid there, because I was going to the conference in Phoenix from 95 to 96, 97, which was the period where that was being bid, the study was being bid. And there were 3 credible proposals that finally went in, which was from McDonnell Douglas, they proposed something which was a DCX outgrowth of DCX technology. There was Lockheed Martin, who had this lifting body technology with the Aerospike engine. And there was also Rockwell, which proposed a design that was effectively an evolved version of the shuttle, using SSMEs, which were again evolved based upon all their knowledge of how to operate. And the concept of the bid was you had to show not only a technical credible case, credible design, but also a business case, because NASA's idea for this was that whoever won it would NASA would fund the development of the prototype, let's call it subscale prototype, but then the company itself would develop an operational version which would take over, eerily like the shuttle, it would take over all launches and things like that. At least that was their hope. And so the requirement to win the bid was one of the key features was the business case. You know, how will you fund it and how will it make money, based upon an understanding of the markets that it was going to capture.
Comes back again.
And this was to me, at the time when NASA did this, about 95, 96, this was a very good way forward. Unfortunately, from some information I heard from people who were actually on the bid team, at the 11th hour, they came into the people who were going to assess the bid and say, okay, no, the rules which we're going to go for is not to have something that's technically the least risk and financially the biggest reward economically. We want to see something that pushes the technology to the bleeding edge. And of course, this is where the Lockheed bid won, because technically it was the most bleeding edge of all technologies. The Rockwell bid, relatively speaking, I use that term cautiously, relatively speaking, was actually very low risk, and the business case was really sound. The Lockheed one was the least economically sound and the most technically risky. But given that I believe NASA were told to change their rankings, X-33 was won by Lockheed, and indeed the Aerospike engine was a concept. Aerospikes have been looked at again back in the 50s and the 60s, but nobody had ever really built one. And so this was going to be the key thing, because when you launch from the ground, the bell normally of a rocket engine has to expand the flow to equal the pressure outside. If you over or under expand, you get terrible structural damage done to the bell. And the idea of the Aerospike is that you didn't actually have an external part of the bell. And more importantly, when you ascended, the shape of the exhaust would be matched by the pressure. So it would be pressure compensating. The only way you can do that with a sort of a SSME bell is you'd have a extendable nozzle, something physically that would extend the expansion ratio. But this would be mechanical and it'd be very complicated. So the theory was that the Aerospike engine would always be self-compensating. The problem there is that was a nice theory, and nobody really understood, in particular the transonic, when the vehicle was going transonic, how the expansion would remain attached and the effect on the performance of the vehicle. And this is what Lockheed Martin were going to try to explore by putting a little subsection, one of the unit components of their linear Aerospike, on the back of an SR-71. It was called Laser. I think the thing was going to fly, and they were going to experiment in this sort of transonic, supersonic region. Unfortunately, again, for reasons which may remain unknown, they never managed to actually fly that vehicle. What I was told was it was considered too dangerous because it was going to be fed by hydrogen. The SR-71 was an aging system, and they just didn't think it was a safe system to fly. Added to the fact that NASA's enthusiasm for X-33 was on the wane, and of course the whole program was cancelled in the year 2000 because of other issues which Lockheed had hit with regard to their conformal tank, which was a composite tank which had like double lobes. And not only double lobe, it was also sort of pointed. So it was a very, very complex structure, which they failed on quite a few of the tests. It failed, and eventually they just gave up on it and said it's too complicated. And in 2000, the whole program was cancelled. So that was on the sort of government side. In parallel to all this, so winding back to the 90s still, there was another set of interesting commercial ventures that were going ahead. And where we came in with this, the word new space, and this is where the word new space started, because around about the mid 90s or early 90s, there were two ventures, one in particular, to put up large constellations of communication satellites. There was Iridium, which had about, as we know now, 77 satellites. But more importantly, there was something called Teledesic, which was going to be basically providing internet from space. And they originally had a concept for a constellation that would put over 1,000 satellites into low Earth orbit. And I believe what made that more practical was the engineering, the technology that came out of Brilliant Pebbles, which I think I mentioned before, where the US military had spent huge amounts of money in working out how to mass produce satellite buses by the hundreds, if not thousands, which brought down the cost. And people then, because Brilliant Pebbles was never deployed, the people who'd been looking at it thought they could use it in a commercial world. So Teledesic, which was backed by Craig McCall, this was looked like a very big project, and of course, with thousands of satellites potentially to launch, this changed the market dynamics. So certain groups of people said, okay, if this market becomes real, then suddenly the economics of developing a reusable launch vehicle change, and it tips it in the balance of the reusable over expendable. And on that basis, at least 3, if not 4 companies started to develop fully reusable, fully reusable systems, although they were actually only the first booster stages were fully reusable. The first one was Pioneer rocket planes, launched by Mitch Burnside-Clapp and Robert Zubrin. They formed Pioneer Astronautics. Pioneer rocket plane was going to use a technique of in-flight, I think it was locks they were going to transfer into the vehicle, so it would take off from a runway like a small fighter aircraft with only the fuel on board, so it could have a light undercarriage. And then through tankers in flight, they would fill up with the remainder of the fuel and the oxidizer. And then from there, they would do a boost on a pure rocket engine up into a high suborbital trajectory and push out an expendable stage, which would put things into orbit. So that was one version of a reusable system. The second one was something called Astroliner by Mike Kelly's Kelly Space. And this was going to use another technique, which would be to tow the launch vehicle up into the the top of the sensible atmosphere, off the runway, and then towed behind a 747. This rocket with wings would then fire its engines when it's at the sensible atmosphere, and do a big parabolic arc, and at the top of the arc let out an expendable upper stage, which would then put the payload into orbit. A third variety of this was probably the most, how can I say, it was the most challenging, which was a single stage to orbit helicopter, for want of a better description, from a company led by Bevan McKinney and Gary Hudson. And this was Rotary Rockets. And their concept was very much based upon Gary Hudson's ideas for single stage to orbit that he'd been looking at since the 70s, which was based upon the ideas of single stage to orbit from McDonnell Douglas and Phil Bono in the 60s, which was to have something that looked like a traffic cone, which would be vertical takeoff and vertical landing, very similar to DCX. And the novel thing about this was that it would have, instead of wings, it would actually have a helicopter blade, so that when it did the re-entry, it would slow itself down, not using parachutes or wings, but it would slow itself down with a auto-rotation of a blade and then actually land. And the blades would be powered as well with rotor tip engines. And the best thing about that was they actually built a full-sized structural model and flew it, in the sense that they flew it on the helicopter rotor. And if you go out to Mojave, you can see this thing actually standing there. And if you go on the internet and look at something called ATV, Rotary Rocket ATV, you can actually see this thing flying down the runway on our helicopter blades, powered by tip rockets, powered by basically decomposing peroxide. And unfortunately, with the demise of Teledesic and the obvious technical challenges to some of these concepts, most of those ideas faded about the same time as we're talking of the X-33 fading. So about the year 2000, this, what I call the first wave of new space ventures, commercial ventures, faded. But out of the ashes of those came the next generation. And this was particularly X-Core, which formed out of the propulsion team from Rotary Rockets. And based upon their, if you like, painful knowledge of what happens when you put a really big challenge up for yourself, you know, going all the way to orbit, what they decided to do was to look at the suborbital market to begin with, because clearly to do a suborbital flight only to, say, 100 kilometers, the aerodynamics, the speeds, the whole sort of design requirements are a lot more forgiving, let's say. They're not as demanding. And so they believed they could build smaller vehicles and prove not only the concept of their technology, but more importantly, their ability to develop these vehicles as a team, and also stimulate the markets. So they realized it's not all down to advanced technology. It's using technology that's available in a way that you can tap into what they hoped was going to be a market that was useful. And of course, a lot of these people were looking at markets that were space tourism, so taking people up to 100 kilometers and coming back. And of course, with the advent of the X Prize, which came about in the late 90s, which originally, by the way, was $15 million, and then certain things never materialized, and it eventually only came down to, I think, 5 million or something when it was won by Virgin Galactic. Well, sorry, it wasn't won by Virgin Galactic. This was Scale Composites, Burt Rutan, who won it. Virgin Galactic hooked into it on the last flight and put their sticker on, and that's where the current Virgin Galactic Spaceship Two, that's the genesis of that. But so in the early 2000s, you had X-Core, you had several other groups looking at developing these suborbital systems. As I say, Burt Rutan with the Spaceship One and others. And later, after that, you had Masten Space Systems, Armadillo, which were effectively in that sort of 2005 period. These were hobby shop people. In particular, the Armadillo was set up by, or were funded by John Carmack, who developed Doom and Quake. So he was a sort of a millionaire. He's not a billionaire, but he was a millionaire who developed software and got into developing rockets for a hobby. And these were reusable rockets again. And they developed some really neat technologies. And a lot of their vertical takeoff, vertical landing flights, they eventually won something called the Lunar Lander X Prize. And so those systems were starting to grow. In parallel with that, I think about the same time in 2006 maybe, Jeff Bezos, I think, got interested. At the same time, 2002, I think, was Elon Musk getting interested in rockets. with the Falcon 1 and things like that. So this, the first decade of the 21st century saw lots of things fading out, X-33 and others, the Rotons, the Pioneer rocket planes fading out, and some more and others coming in. In particular, there was lots of other things going on at the same time, but that's sort of a potted history of what was going on in the reusability section, and that led on to the situation we now have, where unfortunately most of those original companies have faded or have been taken over, particularly X-Core, which I thought had one of the best concepts there. They seem to have gone moribund at the moment. Well, I'm sure people will say yes, they're still operational, but in terms of the links, that seems to be on hold at the moment, waiting more funding.
I seem to remember I saw a documentary regarding this project. They still have the frame of this space plane basically there in the headquarters, or it's not, I don't know whether it is the headquarters or just the shop. Still, it's there. They're adding a little bit of things. Of course, the project slowed down a lot compared to the development speed at the beginning of this idea. And I also saw something from Mustang Aerospace. I think they've flown a something similar to the SpaceX Grasshopper concept.
Yeah, Maston.
A few days ago, if I'm not mistaken.
That's right. All these companies evolve, and X-Core evolved to the point where they were almost able to assemble the first links. But again, it was not so much the technology as the money, but I think one thing eroded the other. Their technology in the wing, particularly the shape of the wing and the manufacturing needed to give the wing the desired shape, was just too much, and they didn't have enough money to complete. So I think they ended up with the fuselage and everything, and one wing. And I think that's where it stands at the moment, waiting more funding. But Maston went in another direction. They actually didn't have enough money to develop something that could go fully suborbital to 100 kilometers to the von Karman line. What they did is saw an opportunity to use their vertical takeoff, vertical landing capabilities as a flying test bed for autonomous landing technology, and they've been very successful in getting Draper and other people involved in actually purchasing flights for their sensors and the software that would run it. And then this is essentially a flying testbed that can really test the technologies, and they are pretty successful in that. The other company I think I mentioned was Armadillo, which is John Carmack's company. I have sort of first-hand knowledge there because we, in a little venture we tried to do within our company, actually flew with them on 3 flights back in the end of 2012, beginning of 2013, and they literally crashed out. The flight in January 2013 crashed, and at that point the John Carmack's let's say financial situation was such that he decided he couldn't put any more money in at the moment. And also I think he was involved in lots of other things, and in particular he went into Oculus Rift and things like that. So he was definitely, his focus of attention drifted away from rockets, although I think he still wants to get back into it. So yes, all these various endeavours have come and gone, but the one common thread is that people have become more and more aware of, if you want to actually do this on commercial funding, you've got to do it in some way to bootstrap yourself, which means start off small and grow it. Unfortunately, nobody's actually been able to prove that concept works, and the people who have succeeded really measurably is Musk and Bezos, and they've basically done it on their own dime, and nobody else has been able to do that, although people talk about it. The Vulcan from ULA is going to be partly reusable, but again, this is still on paper probably come out about in the next 4 or 5, 10 years, who knows.
And possibly use an engine coming from Blue Origin, possibly.
Possibly,
We're not
yes.
sure, but they look like they are trying to win this contract.
Yes. This thing about the engine for the Vulcain and the competition there with the AR1, which is essentially a US produced RD180 type thing. But again, it's investment money. Can you justify it? And how much reusability is in there? We don't know. I mean, on the European side now, we have Ariane 6, which is definitely not reusable. But there is now this talk of the Prometheus engine, which is, again, a LOX methane engine, which Kinéis have been working on, and primarily to reduce the cost of the engine down to $1 million a pop, as it were, but also with the capability for reusability designed in from the start, which people I've talked to claim can be done, and I have no doubt that reusable engines can be done. You just have to take the effort and develop them and hone the technology through experience, which costs.
What are your thoughts on this Blue Origin's New Glenn system, which looks to me very similar to the Falcon 9? Do you have any information? Because one of the characteristics of Blue Origin, I remember very distinctively from the beginning, is, I wouldn't say to be secretive, but lot less extrovert compared to SpaceX. I remember for 2 or 3 years, the front page, the home page of the Blue Origin website was just comprising a coat of arms.
Yeah,
of this Gradatin Ferociter logo. And then plus a link if you wanted to submit your CV to go and work for them. But there were no mock-ups, no pictures, no artists,
Indeed.
drawing of nothing. And then all of a sudden now it looks like they are a little bit more open and starting to sell also the image of their own founder. So I don't know. It's I don't know what to think about the New Glenn.
Okay, but remember Blue Origin flew something called the New Shepard,
Yep.
as they termed it, back in 2010, end of 2009-10, which was something that looked like a massive Apollo capsule.
It was remembering me the DCX.
And this was a hydrogen peroxide kerosene powered engine, which it did its job in terms of showing vertical takeoff, vertical landing, but I know that they had a crash of the vehicle, and I think they decided that approach wasn't necessarily the best approach in terms of the engine cycle. So, yeah, they're secretive. I think this just reflects the psychology of the guy who's behind it, and I think it's the same with SpaceX. It's a direct reflection of the psychology of the person, that Jeff Bezos is a little less extrovert than maybe Elon Musk. But I wouldn't like to say that's just my impression. I think if you're a billionaire, quite justifiably you have a big ego and you want to do things your way, and you want to see something. Your way has to be unique and not be seen to be following. However, as you point out, the New Glenn is suspiciously similar to the Falcon 9 in the way it does the takeoff, vertical takeoff and vertical landing. But it seems to be a way and approach for them. I have to say, if it comes to the question which is the right answer and which is working on the solution that's going to be the DC-3, if you like, of in the next 20 years, we're all going to be flying on this. I suspect that it will be neither, because, again, maybe I mentioned this the last time we talked, but I have a view of space and the way we do space in that I don't believe bigger is better. I actually believe that big space can be done just as effectively, if not more so, with small launch vehicles. I therefore look at something that's more on certainly under 10 tons is more than adequate to see off all of our needs, to satisfy all our mission needs for the next 20 years. And the reason that's important is because the smaller these things are, the cheaper they should be to develop. That's not necessarily true, but in principle, they should be easier to develop. And you can have more tests, and the test program is smaller, and you can perfect true reusability that way. With both the SpaceX approach and the Blue Origin approach, the upper stage is going to be difficult to make reusable. Not impossible, it depends on how well you want to make it, but it's going to be a big reusable, it's going to be a big stage to bring back. And I think you can do it better with a smaller system. I mean, this is just my personal view, but I think also the markets could be, for instance, I believe, and I can show on paper at least, that a 4-ton to low Earth orbit vehicle could satisfy all our current communication systems needs to GEO. Now, on the face of it, that sounds crazy, because how can a vehicle that can only get you to LEO satisfy the GEO market? The way I've looked at it is that, well, you don't do it all in one launch. You do it in multiple launches. So what you do is you use the first few launches to set up a kick stage in low Earth orbit, which then on the final launch you attach your communication satellite to. And I'm talking about a normal communication satellite that you could launch on an Ariane. And the simple reason that you only need 4 tons, not 6 tons, as I'm sure your listeners would say, but some of the big ones, Anik, F4 and others, the biggest, 6 or 7 tons. Well, actually, yes, they are 6 or 7 tons sitting on an Ariane 5, but if you look at where that weight is, probably half of that weight is in propellant that the satellite is going to use to go from GTO, the transfer orbit that the Ariane stage puts it in, to GEO. So if you had a shuttle, if you had a little tug system that would go from LEO straight to GEO and ideally come back as a reusable system, all you need to do is place up on that kick stage the satellite at its beginning of life mass. And if you look at the statistics, and I looked at this 20 years ago, and it's still true, they're all under 4 tons at the beginning of life mass. Now, there's a question about the volume. That's another issue. But on paper, I believe you could satisfy the current satellite market with a launch system that only needed to launch into low Earth orbit 4 tons. So that's why I believe in small, but working the system hard. Now, another thing I'd point out about small vehicles for transportation, virtually everything you see in a city, everything that's transported around is transported in on road, on trucks. And most of those trucks are under 10 tons. Even concrete delivery lorries are under 10 tons. So most of the things you see around you are built by transportation systems that are small. If you're going to build a skyscraper, you don't build a transportation system that can move 1,000 tons in one go. You have lots of little things that can move 10 tons. And the other thing I'd put as evidence of what small systems are capable of doing is if you look at the Berlin airlift, where you had a whole city for quite a substantial period of time maintain its whole infrastructure, most of which was delivery of coal, in aircraft that range between 3 tons cargo, which was the DC-3, to the 4-engine version, I think it was the 47, which was 10 tons. So you had a whole city supported by transportation vehicles that could only lift as much as 10 tons, but you used lots of them very frequently. And so this is why I think that for reusable systems, the first generation, it's better to have little systems that you use really, really hard than big systems that you use occasionally. And by occasionally, I mean once every week or so. I'm thinking a system that launch every day. And I think that's the way I would envisage reusability going. But again, this is just based upon my prejudices and my peculiar way of looking at things.
This is for the section where we discussed you being the ultimate dictator of space things in our previous recording.
That's right. So I think one of the ways
You're entitled to that.
that hasn't been tried, but it's a way that Bezos, I think, might be open to, because if he's prepared to spend $1 billion a year on building something like New Glenn, then building a system that can, say, launch half a ton into low Earth orbit, but do it once every other day, a couple of billion would actually allow you to develop one of those. And that system would be useful primarily because once you've perfected it, and I have to stress that, once you've perfected it, once you've made sure it really is safe, that system could be used to launch people to space stations on a routine basis. And that market, going back to markets in elasticity, is highly elastic, because if you look at the world's population, the wealth population is like a pyramid. And okay, the first times you operate this thing, you will do only very, very, very high wealth individuals, and only a small portion of those who actually want to launch. But as you lower the price, the pool of people, as you go down the pyramid, suddenly the cross section of the pyramid gets wider and wider and wider, and the pool of people who potentially would fly becomes bigger and bigger. So the elasticity of the market for flying humans to low Earth orbit is high, is very elastic. And that's why I think a smaller launch vehicle would not only be good from a lower cost to develop, it would actually be able to address markets, the human spaceflight market, far more directly than something that would launch a capsule of, say, 20 people into low Earth orbit in one go.
But then, maybe close to the end, why are they all going the other way? Why, in your opinion, everybody, by everybody I mean Blue Origin and SpaceX, are chasing heavy launchers? Why is SpaceX so obsessed, for example, to finish and launch the Falcon 9 Heavy?
Because Elon Musk is keen to go to Mars. He needs big spacecraft to go to Mars, and he doesn't want to. He can't do that with ultra small spacecraft. I mean, there comes a time when you have to go from a DC-3 to an even bigger aircraft, to a jumbo jet. But that's when the market's big enough. Now, he believes his market of colonists is going to be big enough to justify this, the big transport. But his ultimate goal is to go to Mars. So he's not really interested in fostering other markets. Now, Bezos is different. Bezos is, as we mentioned before, Bezos' vision of the future is not that he puts himself in space and colonizes Mars. He wants to, if you like, offload the planets, all the heavy industry and things like that. That, I think, would be more amenable to the approach I've mentioned, but only as a first phase. Eventually, if you're going to put power satellites up there and other industrial facilities, you're going to want bigger and bigger vehicles. But I guess my point would be, what you really need to do is prove the concept with something small, something DC-3 size, before you go and build your 747, because in fact there's a parallel in aviation where the DC-3 and then Howard Hughes built the Spruce Goose. And what happened to that? There was no market at the time. Eventually there would be a market, and then we got the 747 and TriStars and all the other big jets. But again, to go back to the original point for reusability and how you design your vehicle, it has as much to do with the markets and the way you see the markets developing as it has to do with the technologies that you need to actually build that. And of course, the third leg of the business case there is you have to have people who are capable of building these vehicles. And that's another resource that SpaceX and Blue Origin are now establishing, a group of people who can actually build and test reusable vehicles. So the answer is I don't know what the future holds, but I would like to see somebody, especially Bezos, Jeff Bezos go and try the small is beautiful route in order to maybe then accelerate, the big is beautiful route. But if just by going big, I think there's maybe a problem there because the elasticity of the big market just isn't there yet. But anyway, that's just one man's view, as it were.
We'll see what the future holds for us.
Yeah, okay.
Good.
Yeah, from the point of view of trawling my mind for the subject of launches and reusability and where it started from and all the phases it's gone through and the drivers of reusability, I think in a muddled way all the key points are there. And if somebody's got other views and other insights on it, it'd be interesting to find out. But I think that's sort of is as much as we can sensibly say at the moment. Yeah.
Then thank you very much again for your time.
Okay, thank you again. Bye.